This video explains the topic of running a correlation. As you know from our class discussions, correlations are when we compare and examine two scale variables and look at their relationship with each other. With correlations, we don't expect one causes the other. We expect them just to be related somehow, meaning they move together based on a relationship that's observed between the variables. I'm going to be using a couple of different data sets to explain some examples, but let me start off with showing how to run a correlation in SPSS, and this is with the survey data that we did in class, not the movie theater data for the first few examples. So for a correlation, we go to Analyze, and then we select Correlate, and then the menu option after that is Bivariate. So it's Analyze, Correlate, Bivariate. At this point, let me remove these variables. At this point, just like a typical menu option, we select the variables that we're interested in exploring and moving those over to the right. So let's start off with looking first off with our satisfaction with Chico State, and then also looking at our satisfaction within the College of Business. Now when we run a correlation, the first time we do these correlations for a sitting with SPSS, we need to select the Options button and make sure that Means and Standard Deviations is selected. Once you've selected it, it'll stay selected for all of the correlations that you run during that test, or during that time period that you have SPSS opened. You also want to make sure that Pearson is selected in the correlation coefficients set of options. The first one should be Pearson. Select that, and then you say OK, and we'll get the output from this correlation between satisfaction with Chico State and satisfaction with the College of Business. Now, when we look at the output window when the correlation is run, there's a couple of things that we want to pay attention to. First of all, the descriptive statistics are nice information. You look at means, but what we're really interested in here down is in this correlations table. There are 2 bits of information that we want to notice. Notice there's a Pearson correlation and a significance two-tailed, which is our p-value. You'll see that in this correlation table, the information in this lower left box and the upper right box is identical information. It's the same information repeated twice. So I typically go to the upper right box and you read across the Pearson correlation. This is our R statistic of 0.682. And the significance two-tailed, this is our p-value of 0.000. So from this table you can see a couple of things. Number one, as you know, with a p-value of 0.000, that is a highly statistically significant result, so we're pleased with that outcome. In addition, we look at the R statistic for correlations, and remember our rules of thumb with the R statistic as we talked about in class. We like to see R statistics, the higher they are, the closer to 1 they are, the stronger the correlation is. And here in this example you see that the correlation is 0.682, or you could refer to that as 68.2%. As far as the correlation. We also, with the R value, look for the positive or negative sign in front of the R statistic, which tells us whether that relationship is positive or negative. Since there's no sign, it means it's a positive correlation. So the correlation is a positive direction, meaning that as the satisfaction with Chico State goes up, satisfaction with the College of Business also goes up. If there was a negative sign, it would mean as one goes up, the other goes down. So we look at the p-value, the R statistic, to understand a correlation. So that's a simple example of a correlation. Let's run a few others just to see some practice with this. If we go back to our data, and we can run another correlation, so we analyze, correlate, and bivariate. We can remove these 2 variables. And let's try a different correlation. Let's look at the importance of relaxing downtime, was one of the questions on the survey, and the importance of the rush of risky behavior, and see what happens with that correlation. Here's our correlation table, and you can see the same pattern of information here and here is repeated, so I just look to the upper left corner. The p-value, the significance two-tailed, p is 0.033, again less than 0.10, so we have a significant finding. Notice the R statistic here is a negative 0.301, so it's a reasonably low correlation. However, the importance here is the negative sign, meaning that as one of these variables goes up, the other goes down. So as students find relaxing downtime important, that's the rush of risky behavior is less important to them. So these 2 variables have a negative correlation, but the p-value shows us that it's statistically significant. We can also do analyze, correlate, bivariate, and let's look at a different set of relationships with 2 variables. Let's explore the importance of healthy eating and the importance of satisfaction with Chico State. This example is to show you a statistically insignificant or not significant finding. The p-value is 0.899, very highly non-significant. And you see the correlation very, very low of 0.19. So this is what it would look like when you have a non-significant finding with a correlation. Now you could run the same types of correlations with the movie theater data. Let me show you just one of those as a way so you can follow along and test yourself to see if you get the same result. So let's do an analyze correlate bivariate, and this is with the movie theater data, so let me get rid of those. Let's run the importance of going to the movies, question 2, by physically active, which is question 9. When you see the output for this, you look for the p-value. P-value 0.216 means it's non-significant since that's higher than 0.10, and the correlation or the R statistic 0.059, relatively low, and it's a positive number, so we can make a conclusion based on that. So those are what we call simple correlations from class. Before I finish the video, let me show you just real quickly one very complex correlation where you can look at a variety of factors. I'm going to jump back over to the Question Pro survey that you did in class, and what I'd like to do is look at a more complex relationship so you can see what happens when we run a correlation. It's still correlate bivariate, but what I'd like to do at this point is I want to look at the variables of healthy eating and regular exercise. Now, in addition to just those two, as you remember in class with complex correlations, we can look at a variety of variables. Let's also, in addition to these two, look at all of the satisfaction measures that we had on the survey. There was a satisfaction of general life happiness, Chico State, College of Business, professors at Chico State, and our current housing situation. This is what a complex correlation output table looks like. As you can see, it's much more complicated. There's more information here, but there's an easy way to analyze a lot of this. Now notice the variables are listed across the top and also down the side: healthy eating, regular exercise, general life happiness, and so on. Those same variables are listed across the top. So this quadrant here that's labeled 1 with a Pearson correlation or an R statistic of 1 shows us that the correlation is a perfect correlation of 1.0. It's because we're correlating healthy eating to healthy eating. Notice on what's called the diagonal, all of these have an exact correlation of 1 because they're all comparing the housing situation with the housing situation. So of course it's an exact perfect correlation. The information above this diagonal line, all of these statistics up here and the numbers below the line, all of them down here, are identical and exactly the same. So what I like to do is I like to pick one set of numbers either above or below the diagonal, and you get the same information. What I do also is I start to look at the p-values, and I notice the p-values are the numbers, the statistics in the middle. I start to see this one is significant, 0.742 means not significant. I see a variety of not significant findings, but then I also see a few very statistically significant findings. So I'd like to look to see what's happening. And so I can look at a pattern of the housing situation and which variables it's correlated significantly with. It's correlated significantly with general life happiness and satisfaction with Chico State and the College of Business, but not with regular exercise nor with healthy eating. I can look at the professors at Chico State, satisfaction with them, and how that correlates to various variables, which ones are statistically significant and not. So a complex correlation uses exactly the same pattern of information. It simply has more variables in the correlation table, so there's more to see, but it's nice to run complex correlations because it saves you from running simple correlations over and over and over with two variables. I like to look at lots of variables at the same time to start to understand what's happening with the correlations. So that's the example of how to run a correlation and a little bit about the interpretation. The next video that you'll see will be about regression.